T vector is equal to m vector cross b vector. Again, m vector means n cap vector. Okay, what is n cap vector? N cap vector is a vector that is perpendicular to the surface that is formed by IA, because I is flowing in the loop. Loop forms a surface, then this n cap is a surface vector of that loop. Okay, so again, theta is the angle between the n cap vector and magnetic field B. So that is theta, sine theta. Next, suppose the loop is in some other direction, say at any point of time t is equal to m vector cross b vector. You know the direction of b vector that is fixed, but the direction of m vector is actually varying as the loop moves, as the loop rotates. Definitely the vector also will rotate. So the perpendicular vector n cap will vary. So at any point of time, what is m vector? M vector is IA into n cap. So what is IA? IA is the current loop. Okay, if this is the current, if it is flowing in this loop, this will form some area that is A. Okay, I is the current flowing in that loop area with area A. So this is the current loop. It forms the plane. Okay, once if you have the plane, definitely you can draw the perpendicular vector. Okay, that n cap is this one. Suppose if your loop is like this, then this is your perpendicular vector, or otherwise you can draw the vector like this also. It all depends on the scenario. Okay, you can draw vector like this also, or because this is also a surface vector. Okay, this is also a surface vector for that particular surface. Okay, so next almost magnetic field is over. Magnetic field related things are over. Now we'll see some of the left out topics in electric field. Okay, in case of electric field, epsilon is equal to epsilon naught into epsilon r. You know, epsilon naught means permittivity of the free space, and epsilon r is the relative permittivity, and this can be replaced by 1 plus psi. So epsilon r is equal to 1 plus psi. Very clearly the psi is having no unit because epsilon r has no unit. So very clearly psi is also having no unit. Okay, so this is the relationship. Okay, again psi is the electrical susceptibility, electric susceptibility. Okay, similar to the magnetic susceptibility is psi. Here psi means electric susceptibility. Okay, so next, what is dielectric strength or breakdown? What is the dielectric strength or breakdown? Generally dielectric is used to store the energy. And the dielectric is having two type of application, two type of major application. One is to store the energy, and another one is to act as a insulator actually. Okay, what is the important things of dielectric? Dielectric, the two main application of dielectric is to act as an insulator, and to store the energy. Okay, in case of capacitor, dielectric store the energy. Okay, to store the energy. Okay, or otherwise it can be used as insulator also. Okay, so dielectric act as insulator, it stores the energy. Okay, you know that air itself is a dielectric, similar to the air, plastic, and some other material. They are all dielectrics, so it will not conduct a current. But even the air also, at some time, it conducts the current. Say, for example, we are calling it as a air as a dielectric. Okay, air is a dielectric, but you know, during the lightning and thundering, air itself conducts a current. Okay, during lightning and thundering, air itself conducts a current. That's why you are getting a light. Okay, as there is a current between the positive charge and negative charge, then really there is a current. That's why you are getting lightning and thundering. So air is actually a dielectric. But during lightning thundering, the dielectric breaks down. Okay, because dielectric acts as a insulator. The insulator. Okay, whenever there is the electric field is very, very high, under very high electric field. Okay, under very high electric field, very high E field, under very high electric field, the insulator breaks down. Under very high electric field, the insulator breakdowns. Insulator or dielectric breaks down. Okay, it's very clear that once it breaks down, then it acts as a conductor. Once if the dielectric or insulator breaks down, it acts as a conductor. When it will break down? Under a very high electric field. Under very high electric field. When the electric field will be very, very high, so you know that electric field is equal to V by D. When D is constant, okay, when D is constant, suppose if you keep on increasing V, then your electric field also will increase. Then finally electric field will increase, then definitely there will be the breakdown. Definitely there will be the breakdown. That is called as dielectric. So it is very simple. As you increase the electric field value for a dielectric material, there is a breakdown. Once if it breaks down, then it acts as a conductor. Okay, once if it is a breakdown, after breakdown, it acts as a conductor. Okay, it acts as a conductor. That means what? It is having large number of electrons. Okay, after breakdown, the breakdown introduces a large number of electrons. You know that from the basics of electronics, the Zener breakdown or avalanche breakdown. Once there is a breakdown, then it introduces large number of electrons. Once there is a large number of electrons, it acts as a conductor. So the breakdown introduces a large number of electrons. It introduce large number of electrons. It introduce large electrons. Okay, breakdown introduce large number of electrons. Okay, so so what is the statement? Dielectric strength or breakdown under large electric field, dielectric becomes as a conductor. It is because due to the presence of large number of electrons, the phenomenon of breakdown introduce a large number of electrons. Okay, so this is called as breakdown. Then what is exactly the dielectric strength? Then okay, what do you mean by the dielectric strength? Okay, the maximum electric field that you can apply is called as dielectric strength. Okay, so what is the meaning of dielectric strength? Okay, minimum value of applied E field, minimum value of E field at which dielectric breaks down is called dielectric strength. Okay, it's something tricky because sometimes they are telling maximum or minimum. Okay, I altered. So what is this? Say for example, if you are having capacitor like this. Okay, say again capacitor is having some D, and then definitely there will be some voltage rating. Say for example, the voltage rating is 100 volt. That means what? You cannot apply more than 100 volt. Okay, you cannot apply more than 100 volt because anyway D is fixed. Okay, but instead of 100 volt, if you are applying 1000 volt, what will happen? Okay, once if you apply 100 volt, say my electric field is something like say 1000 volt per meter, because electric field depends on D, distance between the plate. If the plate distance, if I am taking as a 10 power minus 3 meter, okay, 10 power minus 3 meter, then definitely the electric field will be like this. Say that D is fixed. For simplicity, I am taking D as a 10 power minus 3 meter. Okay, if D is not 10 power minus 3 meter, it is like okay, if it is 10 power minus 3 meter, definitely then electric field, I think not this one. Okay, it would have been 100 k volt per meter. Okay, if D is 10 power minus 3 meter, then electric field would be 10 kilovolt per meter. Okay, if apply this one, then what happens? Then electric field, so in this case, the electric field would be 1000 kilovolt per meter. Okay, 1000 kilovolt per meter. Definitely there will be the breakdown, because maximum you can apply 100 kilovolt per meter. Okay, per meter, but you are applying 1000 kilovolt per meter. 1000 kilovolt per meter. Definitely there will be the breakdown. Now the definitely once if you apply more than this one, definitely there will be the breakdown. Okay, now here there will be the breakdown. Okay, so what is the meaning here? If E is greater than 100k, if E is greater than 100k, 100 kilovolt per meter, definitely there will be the breakdown. So that's why the minimum value of the applied E field. Okay, this is the minimum value. So if you apply 200 kilovolt, if you apply 200 kilovolt, then definitely there will be the breakdown. Even if you apply 300 kilovolt, there will be the breakdown. For 1000 kilovolt also there will be the breakdown. Then what is the minimum value? Okay, if E is greater than 100 kilovolt, definitely there will be the breakdown. So the minimum value here is 100 kilovolt. For more than that, definitely there will be the breakdown. Okay, so or otherwise you can also write this definition in the other manner. What is the maximum electric field that it can be applied without breakdown? Okay, you can write the definition in another way also. What is electric strength? Dielectric strength is called as maximum E field, that can be applied without breakdown. Maximum E field that can be applied without breakdown. What is that maximum electric field here? Maximum you can apply what? In our case, 100 kilovolt per meter. Okay, it's all definition in what way they are defining. Okay, from this side or from that side. Okay, that is the idea. That's why minimum maximum shifts. Okay, so this is a simple idea of the dielectric strength and breakdown. Okay, next, what is the capacitor? What is the capacitor? Then you take it as an exercise. You try to calculate what is the dielectric strength. For different dielectric. For example, for air, what is the dielectric? For plastic, what is the dielectric? For glass, what is the dielectric? Is there any other material which provides high dielectric strength, like a transformer oil? Okay, in the transformer we are using some oil. I think you would have seen transformer oil. It is having some dielectric strength. What is the transformer oil dielectric strength? You just try to find out dielectric strength of various material. Okay, various material, or it may be solid or liquid also. Okay, so transformer oil, something like that. Okay, even we are using the oil in starter, motor starter. In starter also we are using the oil. In starter oil, what is the dielectric strength of that oil? Okay, again, why we are replacing the oil after few times we are replacing the oil? Why? Okay, so just try to find out the dielectric strength of various materials. Okay, next, capacitance of the coaxial cable. Okay, capacitance of the coaxial cable. Okay, you know that whenever there is a coaxial cable, there will be inner conductor and there will be the outer conductor. Okay, and this is the length of the cable. So I take the length of the cable as L. This is the length of the cable. This is the inner radius, and this is the outer radius B. And I know that just now we have calculated what is the inductance value. What is the inductance value for the coaxial cable? Just now we have calculated the inductance value L by D is equal to mu divided by 2 pi ln B by A. Ln B by A. Similar to that, now we are calculating the capacitance. So now the capacitance is C divided by L, 2 pi epsilon ln B by A. Ln B by A. Suppose if you want to have a capacitance, it is very simply 2 pi epsilon L ln B by A. Ln B by A. Okay, again, always that unit relationship has to be satisfied. Okay, what is C by L? What is the unit of C by L? What is the unit of this one? C by L, capacitance in farad. This is meter, farad per meter. Again, what is the unit of epsilon? That itself is a farad per meter, but ln B by A has a no unit because B by A cancel each other. So always you should be very careful whether whatever we are writing, whether that is satisfying the unit relationship or not. Okay, so unit of this one is farad per meter. Unit of this one is capacitance, simply farad. Okay, simply farad. Now you know what is for a coaxial cable. You know what is the inductance. You know what is the capacitance. Now I define one new parameter. That parameter will be useful in transmission lines. Okay, so or otherwise, if there is Z0, okay, Z0, then Z0 is equal to L divided by C. And you know what is L? Okay, inductance. You know what is capacitance. Okay, once if you substitute everything, then it comes as a mu divided by epsilon. Okay, mu divided by epsilon. If it is a free space, really the mediums are free space, then it is mu naught divided by epsilon naught. Okay, then what is mu naught value? 4 pi into 10 power minus 7. This value is 8.854 into 10 power minus 12 square root. You just try to find out what is this value. Okay, just try to find out what is this value. Okay, with the help of calculator. Okay, then that value will be really useful in later classes. Okay, I think it should come around 377 ohm. Okay, so next, what is the capacitance due to spherical shell? What is the capacitor due to spherical shell? Spherical capacitors. Okay, spherical capacitors. The shape of the spherical capacitor, see, this is a conductor, and you will have one more conductor like this, okay, like a hollow conductor. Here, the in between the medium may be air, or it may be filled with some dielectric material, but this is a conductor. Okay, here the radius of this conductor is A, and this conductor is B. Okay, once if you connect it with some voltage, then what is the maximum energy that it can store? It's very clear that once if you apply the voltage between these two conductor, this is very clearly acting as a parallel plate. You know that the surface areas, okay, the surface area of the smaller circle and the surface area of the bigger circle is acting as individual surfaces, and again they are parallel to each other, and again they are separated by some distance, and they are separated. This is something similar to this one only. Okay, whenever you are having two plate, this is upper plate where you will store positive charges, here you will store negative charges. In between you will collect your battery plus and minus. Similarly, here also you can collect plus terminal and here minus terminal. Finally, it will also store some energy. Then what is the energy stored by this system? Okay, so what is this energy? So first of all, you should know what is the capacitance value. So the capacitance of this structure C is equal to 4 pi epsilon divided by 1 minus A divided by 1 minus B. C divided by 1 minus B is farad. Okay, and again, what happens if there is only smaller conductor, if there is no larger conductor? Okay, that is also possible. If there is no larger conductor, and again here also you should look whether is it satisfying the unit relationship or not. Okay, what is the epsilon farad per meter? Again here meter is there, that will go in up, and then meter cancel. So this is farad and this is also farad. Okay, that is the idea, because in future, because why I'm telling like this, in future you should not get doubt like this. You should not write like this. This is very much wrong, because once if you write like this will become farad per meter, and this is meter. Finally, a capacitor unit is coming as farad per meter square. That is very much wrong. So then you should correct it. Okay, that's not A minus B. That is 1 by A minus 1 by B. Some simple idea I'm giving you to remember this formula, if at all if you are making mistake in future. Okay, so okay, now what is the capacitor due to the single isolated sphere? Okay, now there are two spheres. Okay, if there is a single sphere, what is the capacitance value? Okay, capacitance due to single isolated sphere. Okay, capacitance due to single isolated sphere. Okay, what is the capacitance due to single isolated sphere? Only there is one sphere. Say for example, only you are having this structure alone. Say this structure alone. Okay, now what is the charge energy that you can store in this structure? What is the energy that you can store? And if it is storing say plus charges, then where the minus charges will be stored? It is assumed that will be stored on the infinite sphere. That will be stored on the infinite sphere. Okay, so what is the capacitance of this one? Okay, here if the radius is A, so now the capacitance value C is equal to 4 pi epsilon A, 4 pi epsilon A. Okay, because you substitute B is equal to infinite. Okay, once B is infinite, in the beginning itself I've told only if there is one sphere, then the negative charges will be stored on the sphere, imaginary sphere that is present at infinite distance. Okay, that's why B I am taking it as infinite. Once if B is infinite, then okay, 1 by infinity is 0, then A goes up, then 4 pi epsilon A farad is the answer. A farad is the answer. Okay, A farad is the answer. Okay, so now okay, so next one is again you think over. Suppose if A is equal to B, what happens? Okay, you are having two conductors. You are having two conductors. Okay, now if A is equal to B, what happens? Just imagine what will come. Okay, either infinity or zero. Okay, what is the answer? Why it is coming like that? Okay, in which case it becomes like this. What happens once if both the conductor merge together? Okay, next, the conductance and capacitance theorem. Conductance and capacitance theorem. It means just is there any relationship between the conductance and capacitance? Conductance and capacitance theorem. Just we are going to analyze the relationship between the conductance and capacitance. We know individually what is conductance. 1 by resistivity is called conductivity. Okay, or 1 by resistance is called conductance. Okay, you know these basic relations. Okay, say G is equal to 1 by R. Conductivity is equal to what, sir? 1 by rho. These are all simple basic relationship that you know. Okay, so next, what is C? Okay, for a capacitance, for a parallel plate capacitance, C is equal to epsilon A divided by D. Again, for analysis purpose, I am taking it as a L. There is no problem because I am assuming instead of D, I am putting L. That's it. L means what? Distance between the plate. L means distance between the plates. Then what is the relation between the resistance and the resistivity? You know that resistivity is equal to, sorry, resistant is equal to rho L divided by A. Rho L divided by A.
கொஞ்சமா
Okay.
ஒரு glass வேணும்.
Yes. Mute the mic. Hello.
9.
Yes, Karthi, mute the mic. Okay, so rho L divided by A. Again, what is 1 by R? Once if you reverse, that is 1 by R, then this is A divided by rho L. This is A divided by rho L. Again, 1 by rho can be written as sigma A divided by L, conductivity into A divided by L. Now, you know what is capacitance, you know what is conductance. Okay, you know what is conductance. Then finally, if you find out the ratio between the conductance and capacitance, G divided by C is equal to epsilon A divided by L. C is equal to sigma A divided by L. Then finally, this is something equal to sigma divided by epsilon. Then G can be written as sigma divided by epsilon into C. Okay, so finally you are writing this one. Then you try to prove the unit relationship. Unit, you know the unit of G, you know unit of conductivity, you know unit of the permittivity, you know unit of the unit of what, capacitance. Finally you prove that the unit on both the sides are same. Okay, unit on both the sides are same. Okay, so that means what's are in some cases, if G is there, if these parameters are given, the G can be replaced by this equation. That is the idea. Okay, so next we'll try to make we'll try to make some other relationship. Okay, the same relationship we'll try to derive in some different way. Okay, we'll try to derive in, okay, the same relationship. Okay, that G is equal to sigma C divided by epsilon. We'll try to derive it in some different way. Okay, so okay, you know that I is equal to integral J dot ds. Again, J can be written as what, sir? Sigma into E. This is very, very important. J is equal to sigma E is called Ohm's law in electromagnetics. Okay, J is equal to sigma E is called as Ohm's law in electromagnetics. J is equal to sigma E ds, and integral E dot ds, integral E dot ds. You know one thing, integral D dot ds is equal to what, sir? Q. Integral D dot ds is equal to Q. So again, integral D can be replaced by what? D is equal to epsilon E. So epsilon into E D dot ds Q. So this can be E dot ds, and q divided by epsilon. So integral E dot ds can be replaced by q divided by epsilon. So I is equal to conductivity q divided by epsilon. Okay, q divided by epsilon. You know what is I? I is equal to v by r. What is I? I is equal to v by r. You know what is q? Q is equal to cv divided by epsilon. Okay, divided by epsilon. Okay, so v cancels. So then finally we are getting 1 by r sigma c divided by epsilon. Okay, you know that 1 by r is equal to what? G. Just now we have proved that G is equal to what? Conductivity into C divided by epsilon in the previous slide. So G is equal to what? Conductivity C divided by epsilon. Same thing we are getting here also. Okay, so next we'll try to derive Ohm's law. Okay, J is equal to sigma E. We'll try to derive this one. How J is equal to sigma E from the basics. Okay, so now Ohm's law. Okay, please wait for a few minutes, 10 more minutes it will be continued. Okay, exactly 10:15 we will finish. Okay, Ohm's law is equal to what? I is equal to, you know, from circuit theory, I is equal to V by R. R can be replaced by rho L divided by A. R can be replaced by this one. Then from this, what is I? I is equal to VA divided by rho L. I is equal to VA divided by rho L. The next step, if you bring A downside, I divided by A, okay, V divided by L, that rho can be written separately. Okay, then what is I divided by A? That is J. V divided by L, voltage divided by length is called electric field, and 1 by rho is called conductivity. 1 by rho is called what, sir? Conductivity. So J is equal to sigma E. Once if you rearrange this equation, J is equal to what? Sigma into E. Okay, because I is also Ohm's law, J is equal to sigma also a Ohm's law. So this is the point form of Ohm's law. J is equal to sigma E is called point forms of Ohm's law. This is very important. This is called point form of Ohm's law. Okay, that what is point form in the sense, suppose if you are on the space, if the space is having some conductivity, okay, if you know the electric field at that point, if you know the conductivity at that point, then at that point you can know what is the current density. Okay, space current density. Okay, this is the point form of Ohm's law. J is equal to sigma E. J is equal to sigma E. Next, next Joule law. Okay, Joule means something related to the energy. Okay, you know that energy is equal to what, sir? Power into time. Energy is equal to power into time. You know, power is equal to, in circuit analysis, I square R, time is T. Okay, time is T. So I square R into T, or otherwise power is equal to, if it is power, that is I square R, or V square divided by R, or it can also be written as V into I. Okay, so now power P is equal to V into I. Okay, now I'm introducing something. Okay, I'm just multiplying with A into L. Okay, and again dividing by A into L. Okay, A into L means what? It gives you volume. Area into length will give you volume. Okay, AL divided by AL. Once in this AL, I am writing it as just rearranging. Anyway, V divided by L. One is V divided by L, and another one is I divided by A, and another one is I divided by A. Okay, L is there, A is there, VA is there. Then what is remaining? AL is remaining. Okay, this V divided by L, I can write it as E, electric field. This I divided by A, I can write it as J. This AL, I can write it as a volume because area into length is called volume. So this is power. Okay, power is equal to what? EJ, E into J, volume. Or in integral form, you can write it like this. Volume integral E vector dot J vector dV power. So power can also be written like this. In free space, if you know what is your current density at that point, what is your electric field, then you can calculate the power. Because again, there is one more relationship. J is equal to what? Sigma into E. So this is the energy relationship. Sometime in the exam, they will give you what is the energy. Okay, they may give you this format also. Volume integral E dot J dV. Okay, this is the power. Okay, power. Yes. With this, I will complete today. Any doubt?